This is the final lesson in Unit 3 and the final lesson of Algebra 1B, 3.9, the quadratic formula. The objectives of this lesson is that you can determine the value of A, B, and C from a quadratic equation. You actually have already done this before when you were factoring. You can determine the quadratic equation will have 0, 1, or 2 solutions using the discriminant. So we found out when we were factoring quadratic equations that our solution may be 1 or 2 answers. We'll find out that if it's not factorable, then you can use this formula today to find out if there's no solutions, 1 or 2 solutions. You can solve the quadratic equations by using the quadratic formula. And finally, you can identify the solutions of a quadratic equation. Let's first recall the standard form of a quadratic equation. A quadratic equation is an equation that can be written in the form ax squared plus or minus a bx plus or minus a c is equal to 0. Basically, the standard form of a quadratic equation means that the expression has to be set equal to 0 with your descending degrees. So look at question 7. It says cross out the quadratic equation that's not in standard form. Well, if you look at the first one, it's x squared minus 81. It's set equal to 0, so we're good there. And we have our descending exponents, so x squared minus 81, so there's no x, so that's fine. The second one, 12x squared equals 6x plus 20. That's not set equal to 0 at all, so it's not that one, nor is this next one. It's not equal to 0. So one of the first skills you're going to have is to always make sure with quadratics that you have the quadratic in standard form first. In the previous lessons, we then turned them into factor forms to solve them, but we found out that sometimes you couldn't factor them. So we have to put these equations in standard form to use our quadratic formula that's coming up next. Let's look at column A and column B. You're trying to match them. Do the first problem, x squared plus 3x plus 18 is equal to, equals 5x plus 11. So we need to move that 5x to the other side of the equation as a negative 5x. We also need to move that 11 over as a negative 11, so you change the sign. Combine like terms, you get x squared minus 2x, because the bigger sign is negative, plus 7 is finally equal to 0. So that one matches that one right there. Look at the next question. You have 3x squared plus x equals x squared minus 1. You need to move the x squared over as a negative x squared. We need to move the 1 over as a positive 1. Let's combine like terms. You get 2x squared plus x, that's the next term, and then plus 1, the constant, is equal to 0. So that would be that one. Now it's pretty obvious the one that's left over should equal that one, but let's just prove it. You have 3x plus 5 squared is equal to 0. Now you can work one way or the other. You could have taken the standard form that they have that you're trying to match and try to factor it to get column A, or we can take column A and multiply it out. Notice that this is a binomial squared, so we need to rewrite that as two separate binomials that you're multiplying together. And then use whichever method that you prefer. You can use the box method, stack it, or FOIL. I'm going to go ahead and FOIL it this time. And I did make a boo-boo there on on the F there. I'll erase it here in just a second. Here, let me back up. I'll go ahead and do it. So if I'm going to FOIL this, multiply my first two terms, 3 times 3 is 9x squared. Outside would be 15x. Inside is another 15x. I combine those together to get 30x. And then last, it's my 5 times 5 is plus 25 is equal to 0. So there you go. As long as you have your quadratic and standard form, you can figure out the discriminant. The discriminant is a formula, b squared minus 4ac, where you get the b is the coefficient of your x term, the a is the coefficient of your x squared term, and your c is your constant. The value of the discriminant tells us how many real number solutions a quadratic equation has. If the number of real solutions, if the discriminant, if you plug in those values, the b, a, and c, into that equation, if your answer is positive, then you'll have 2 solutions. If it's 0, then you'll have 1, and if it's a negative number, you'll have 0 solutions. So knowing the discriminant formula will help you determine how many solutions you should have to the problem. So let's practice calculating a discriminant. Let's remember though that the formula b squared minus 4ac, if we solve that and it equals a positive number, then we should have 2 solutions. If it equals 0, then we should have 1 solution, but if it's negative, then there is no solutions to the quadratic. Let's look at example 2. 5 is our a value, positive 3 is our b value, and negative 9 is our c value. Don't forget the signs on each one of those numbers. We plug those into the formula, the b squared minus 4ac, but I want you to be careful. Look at the formula. You still must use the order of operations in the formula, so you must solve the exponent first and then do your multiplication before you do any subtraction. This is a very common mistake. So once you find those 2 answers, then you will be adding or subtracting together depending on what sign your minus 4ac turns out to be. So let me demonstrate this for you. B squared, so in this case b is 3, so 3 to the second, minus the quantity 4 times a, which is 5, times c, which is negative 9. Notice how I wrote it with the a and c in parentheses. Now that I have a numeric expression, I must follow the order of operations. I start and do my exponent first. 3 to the second, that's 3 times 3, is 9. And then I have to go to the multiplication. So even though that looks like minus 4 times 5 times negative 9, treat that minus 4 as a negative 4 at this point because it's sitting side by side to parentheses, which means multiplication. So if you multiply negative 4 times 5 and then multiply that by negative 9, what do you get? Well, negative 4 times 5 is negative 20, and if we multiply that by negative 9, we get, well, a negative times a negative is a positive. And what did I do here? Oops, I was subtracting. Let me back that up. So negative 9, or negative 20 times negative 9, that's 180. And a negative times a negative is a positive, so that's a positive 180. Remember, all I'm trying to find out if my answer is going to be positive, negative, or 0. Well, if I take 2 positive numbers and I add them together like this, 9 and 180, sure it comes out to 189, but what I care about is whether or not it's a positive or not. And this time it is. So therefore, this quadratic, if we were to solve it, should have 2 solutions. In question number 3, if we fill that in for into the equation. B squared, so that's negative 2 squared. Notice I put the negative inside parentheses. If you're using a calculator, this is very important that you also use parentheses with your calculator if you're trying to figure out what negative 2 squared is equal to. Minus 4 times A, which is 3, times C, which is 7. Once again, I need to follow the order of operations, so do my exponents first. Negative 2 to the second power. It would not matter if that was a negative or a positive inside parentheses. Whenever you take a number to an even power, in this case the 2, you should always get a positive answer. So negative 2 to the second power is positive 4. Then I need to do my multiplication. So I'm going to multiply negative 4 times 3 times 7. Well, negative 4 times 3 is negative 12 times positive 7. A negative times a positive equals a negative. 14, carry my 1, 7, 84. So negative 84. Now I have 4 minus 84, or positive 4 and negative 84. 84 is bigger, so that means our bigger sign is negative. I could solve this all the way out, which is 80 because you'd have to subtract, but all I care about is the fact that this is a negative solution. So therefore, there are no solutions to that quadratic. And the last one, again, use my b squared minus 4ac. So b is negative 4. Negative 4 squared minus 4 times a, which is 1, times c, which is negative 6. Negative 4 squared is a positive 16, and then I need to do my multiplication of all three of those terms together. A negative times a positive 4 times 1 is negative 4, and that negative 4 times the negative 6 equals a positive 24. If I were to add those two numbers together, I would get a positive number, which is all I really care about. Because it's positive, therefore, that quadratic would also have two solutions. Alright, it's your turn to try practicing this. Attempt to do it on your paper. If you want to, you push pause and then check your work. First step is identifying your A, B, and C. So your A is equal to negative 1. Remember, if you don't see a coefficient, then you know that it's 1. B is also equal, there's a 1 in front, so B is equal to 1, and C is equal to negative 8. Watch those signs, they stick with the numbers. So the formula is B squared minus 4AC. B squared, so 1 squared minus 4 times A, which is negative 1, times C, which is negative 8. Now that I have a numeric expression, I follow my order of operations. Exponents, then multiplication, before I add or subtract. 1 squared is just 1. Negative 4 times negative 1 is positive 4. Positive 4 times negative 8 equals a negative 32. So I left with a positive and a negative. The opposite signs subtract. The bigger sign is negative. It would be negative 31. Is there a discriminant? All we care about is the fact that it's a negative, therefore this quadratic has no solutions. So here's what this quadratic looks like on a graph. The reason why we say it has no solutions is because the graph never crosses, whoops. Notice that our graph here never crosses our x-axis. That's why there's no solutions. X can't equal anything. It never crosses the x-axis. Alright, let's try another one. Again, what's the formula for a discriminant? B squared minus 4AC. Here's our B value, so 8 squared minus 4 times A, there's our A, negative 4, times C, there's our C value, negative 4 again. Follow the order of operations now that it's numeric. 8 times 8 is 64. Multiply these three values together. The first two, negative 4 times negative 4 is positive 16. 16 times negative 4 is 24. Carry my 2. 4, 5, 6. It's negative 64. What's 64 minus 64? That's 0. How many solutions would that be then? Just one. This is what that equation would look like if it was graphed. The reason why there's only one solution is look at the maximum point of that parabola. It only touches the x-axis in one spot. That's why there's only one solution. In that graph then we could see what is the solution for this p value. Well, p would be equal to, what is that? 1. Try 3. What's our formula? B squared, can you say it? Minus 4AC. Check your algebra formula sheet. This one might be on there, so you may not have to memorize it. So B squared, that's 5 squared. Oops. 5 squared minus 4 times A times C. 5 squared is 25. Negative 4 times negative 8 is a positive 32. That times the 3, so that's 25 plus, and all we're doing is getting more and more positive, aren't we? We never have any more negative numbers. 3 times 32, what is that, 96? Our answer, regardless, is going to be positive, so we know that we should have 2 solutions. Just realized you're probably hearing snoring. That's my dog. Sleeping and snoring. That's funny. Alright, here's what that quadratic looks like when it's graphed. So the reason why we have 2 solutions is, look here. It crosses the axis right there and then also right there. So that's why we have 2 solutions. So in the previous lessons we learned how to factor quadratics so that we can solve them, but we did discover that there were times that they were not factorable. So today we're going to be introducing the quadratic formula. We like the quadratic formula, or nickname we'll call it Old Faithful, because it works for every quadratic, even the ones that are factorable. It just may take a little bit longer to solve them. The quadratic formula says if you have a quadratic set equal to 0, then x is always equal to, and you read it like this, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. In order for this formula to work, you must set your quadratic formula equal to 0. Now this formula may look a little complicated at first, but do you notice something familiar about this formula? Look, isn't that the discriminant right there formula, right underneath that radical sign? That b squared minus 4ac? So that'll help you with some of this formula. It's something you'll be used to doing. So it's not that you need to memorize the formula exactly, because I'm pretty positive that this one is on your formula sheet, but you do need to be able to know how to use it and use, once you plug in your values, know the order of operations to solve this. Once you plug in your A, B, and C into that formula, the answers that you get using the quadratic formula are called your solutions of the quadratic equation. So let's do this. Here we have a quadratic equation, 3x squared plus 14x plus 8 is equal to 0. Is it set equal to 0? Yes, okay. Now we need to identify our A, B, and C value. A is equal to 3, B is equal to 8, and C is equal to 4. So we plug it into our formula. The beginning of our formula says the opposite of B, or negative B. I'm going to plug in my B value. The opposite of B just says, hey, if this is a positive, then write a negative. If it's a negative, then write a positive. Plus or minus, let's see, now we're ready for the discriminant part. What was it? B squared, so it would be 8 squared, minus 4AC, 3, 4, that's our A and C value, all over 2A. To simplify this, now that it is all numeric on the right-hand side of the equation, we would need to first simplify the discriminant part, or the value that's underneath your radical. So I'm going to write negative 8 plus or minus the square root of, and let's get the value that's our discriminant underneath here. Remember when you did the order of operations, you had to solve the exponent first. That was 16, not 16, that's 8 squared, not 8 times 2. 8 squared is 64. Then do your multiplication. Negative 4 times positive 3 is negative 12 times the 4 is 8, let's see, 4, it's 48. And that is, let's say, a negative 12, that was a times 4, a positive 4 should equal negative 48. So negative 48. 64 minus 48. So what do we get? 14, 6, 16. Yeah, it's much easier to use a calculator on these. So you get the square root of 16 all over 2 times 3. Well, what is 2 times 3? 6. Now we need to take the square root of that 16. Negative 8 plus or minus square root of 16 is 4 all over 6. At this point, what you want to do is, you can either do one of two things. You can rewrite the rest of this problem as two separate problems, one with a positive sign, one with a negative sign, or you can just solve one with the positive and one with the negative. So think of it like this. It's negative 8, if I break it up and show you what they are as separate problems. Negative 8 plus 4 over 6, and the other part of the problem is what is negative 8 minus 4 over 6. So negative 8 plus 4 is negative 4 over 6. And I'm running out of room here, sorry about that. That reduces to negative 2/3. So there's one of our solutions. I'll go back in a minute just to double check my work. Negative 8 over negative 8 minus 4. Those are the same sign, so I have to add bigger sign wins, so it's a negative 12 over 6, which reduces to a negative 2. So there's our two solutions. We knew we were going to get two solutions because when we did our discriminant, this part right here, we got a positive number here. That positive number would let us know that we should get two solutions. So our two solutions, the way you can write them, is x is equal to negative 2/3, or x is equal to negative 2. So that's the answer when we solve the quadratic equation. I hope you're not saying this is too much right now in your head. You can do this. I know you can. It looks more complicated than what it really is. Let's try another one. Identify your A, B, and C. So if A is 6, B is negative 5, C is negative 4, we need to plug those values in. So plugging your negative 5, so it's the opposite of B, plus or minus. Now we're ready for the discriminant underneath our radical. B squared, so negative 5 squared minus 4 times A times C, so that's negative 4, all over 2A. I always simplified this out here, even though you're supposed to do what's underneath the radical first. X is equal to, well, negative times a negative is a positive 5, plus or minus. Now we have to simplify what's underneath the radical, find our discriminant, all over 2A. 2 times 6 is 12. Okay, let's solve our discriminant. Negative 5 to the second power is 25, positive 25. And then we solve this part right here. We have a negative times a positive times a negative. There's two negatives, so we know our answer has to be positive. Oops. 4 times 6 is 24. Take that 24 though and multiply it by sorry about that. I ran out of room again. So we had a negative 24 times a negative 4. A negative times a negative is a positive, so that's why we had that positive up there. 4 times 4 is 16, carry the 1. 4 times 2 is 8, plus 1 is 9, 96. Add those two values together, 25 plus 96. Let me carry it. 1. 121. Whew. Square root of 121, what is that? I think it's 12, isn't it? 5 plus or minus 12, or is it 11? Let me check. I was wrong, it's not 12, it's 11. Because 11 times 11 is 121, that's where that came from. All over 12. Now we need to solve them separately, our positive and our negative. 5 plus 11, all over 12. 5 plus 11 is what, 16 over 12? Which reduces to, I'm going to go ahead and leave it as an improper. Both those numbers can be divided by what? Biggest number 4. So we have 4 over 3. You can use your calculator to simplify it, just make sure you use your fraction button. If we do the 5 minus the 11, you'll get negative 6 all over 12. And reduce that, you get negative 1/2. So there's your two solutions. x is equal to 4/3, or x can be equal to -1/2. We knew we should have gotten two answers because our discriminant was a positive number. Okay, question number 3. Again, identify your A, B, and C. So what's A? You say 1. What's B? 12. And what's C? Uh-oh. Hopefully you did not write 45 yet for C, because look what's the matter here. This equation is not solved for, or is not set equal to 0. I'm going to double check that I did not make a mistake in the previous problem. Yep, that one's set in focus question 2, it's set equal to 0. So you always need to make sure that your equations are set equal to 0. This one is not. We need to first rearrange the problem. Bring your 45 over to the other side, so you should have x squared plus 12x minus 45 is equal to 0. So our A value is 1, our B value, oops, I forgot the x there. B value is 12, and our C value is -45. Would you have gotten this problem wrong had you not set the equation equal to 0 first? Alright, we're ready to plug into our quadratic equation. The quadratic equation says the opposite of B. B is 12 plus or minus B squared, that's the 12, minus 4AC all over 2A. Can't read, oops. Alright, simplify. It's the same as -12 plus or minus the square root of. Your discriminant, we'll solve that here in a second. All over 2 times A, well that's 2. Alright, your discriminant, 12 squared. I don't have a calculator with me today, so I have to do everything long-handed. 4, carry 1, oops, there's not carry 1. 4, 2, it's 144. That 144, hold that thought for a second, then I had to find out what -4 times 1 times -45 is. So -4 times 1 is -4, -4 times -45, 20, 16, 17, 18. Negative times a negative is a positive. So you have 144 plus 180. Keep on simplifying this, plus or minus the square root of, well, 144 plus 180. What is that? 4, 8, 9, 10, 11, 12, carry 1. 324. All over 2. Use your calculator to find out what the square root of 324 is. Okay, I found a calculator. It's equal to 18, that square root of 324 is. So you have x is equal to -12 plus or minus 18 all over 2. Alright, split it up now. -12 plus 18 all over 2, and -12 minus 18 all over 2. Running out of room here. Here I rewrote it. Okay, split it up. X is equal to -12 plus 18 over 2 and -12 minus 18 all over 2. Simplify both of those, so -12 plus 18, what is that? 6 over 2, which reduces to just 3. So x can equal 3, or x can equal 2. Negative 12 and negative 18 equals a negative 30 all over 2, which is equal to negative 15. So our solution to this quadratic could be x is equal to 3 or negative 15. Okay, let's try some guided practice problems. I would like for you to try to start these on your own, maybe push pause and start working on them, push play to start checking as you're going along, make sure that you're getting it right. Stop it whenever you make a mistake, fix it, and then rework the problem. Alright, question number 1. Again, our formula is try this again. Hit the wrong button. There we go. Okay. Alright, the quadratic formula says x is equal to the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Plug in your values. Negative b, so b is equal to negative 12, plus or minus the square root of b squared. B is negative 12 again, squared, minus 4 times a times c. 4 times a times c. All over 2a. Keep on simplifying this now. Negative times a negative is a positive, so 12 plus or minus square root of 12 squared is 144. You might be tempted to write minus right here, but then you might have some double negatives that you'd have to multiply together. Just so that if you want to know what sign to always put down, count how many negatives you have here. I have 2 negatives. As long as my number, I have an even number of negatives, I will have a plus sign here. Otherwise, it'll be negative. 4 times 3 is 12. Get a place to work this out. 12 times, so that's where that came from. That's a negative 12 times a negative 36. I'm going to use the calculator. Okay, it comes out to 432. All over 2 times 3 is 6. Keep on simplifying that radical down. 12 plus or minus the square root of 144 plus 432. That equaled 576. Still over 6 equals, you have 12 plus or minus square root of 576 is 24. All over 6. If you want a shortcut for simplifying this is a complex fraction, it's both of them. If you notice that the 3 numbers that you get here, 12, 24, and 6, those 3 numbers can be divided by the same number, then you can do that to simplify this even further. Or you can just do it the long way, where you do 12 plus 24 and divide it by 6, and 12 minus 24 divided by 6. I'm just trying to shortcut this a little bit for you. So 12, 24, and 6 can all be divided by 6. If I do that, I should get 2 plus or minus, sorry for the on there. 24 divided by 6 is 4. And 6 divided by 6 would just be 1. And it's like over a 1. Therefore, you don't need to write the 1. Does that make it a little bit easier to solve then? Our two solutions, 2 plus 4 is 6, or 2 minus 4 is negative 2. So that's what x is equal to. X is equal to 6 or negative 2. So you can see using the quadratic equation does take quite a while. It is also easy to make little mistakes with your signs along the way. So even though this formula works with every single quadratic, even the ones that are factorable, I'd advise you to try to factor if you can before you try using the quadratic equation. Use it as a last resort. Alright, this one again. So a quadratic equation, again, x is equal to the opposite of b, or negative b, plus or minus b squared minus 4 times a times c, all over 2a. Oops, I wrote a instead of the number. 2, which is 4. Simplify some things up. Negative times 11 is just a negative 11 plus or minus square root of. If you do that discriminant in your calculator, you are going to need to, you're going to need to put some extra parentheses when you put it in the calculator if you're using your calculator. Do solve the discriminant part underneath your radical in your calculator and find out what that number is. Clear your calculator out before you take in the square root, because it will cause some errors otherwise. Where you'll need to put some extra parentheses is right here. If you put this into your calculator, go ahead and do your 11 squared in your calculator, minus, but then use parentheses before you do 4 times negative 20 in your calculator, and then press equals. If you did it right in your calculator, you should get 441 all over 2 times 4 is 8. So now you have negative 11 plus or minus, what is the square root of 441? It's 21 all over 8. So our two solutions, one of them is whatever negative 11 plus 21 over 8 is equal to, and the other one is whatever negative 11 minus 21 all over 8 is equal to. I couldn't use that little shortcut trick I told you about before, where you divide all three numbers by the same number, because there's nothing that goes into 11, 21, and 8. So I'd have to solve it. Negative 11 plus 21 is a positive, is it 10? Yeah. All over 8, which reduces to 5 over 4. So one of our solutions is 5 over 4. The other solution is negative 32 all over 8, which is equal to negative 4. So the other solution is negative 4. All right.